The way that I like to proceed when it comes to the unit on chemical compounds is I like to talk about ionic compounds and then name them, and then talk about molecular compounds and name them. All right? So we're going to separate out these two types of compounds when we learn how to name them. So let's just go over a couple of basic things to get ourselves back into thinking about how we come up with names and formula. And this is a term that I may have mentioned. Again, I can't remember if it was the morning or the afternoon class that I mentioned this to already. But this is a term that I like to use. It is the big chemist's way of talking about the charge on an ion. All right? So we know that ions, stable ions, have charges. And we know how to determine the charge on many stable ions, +1, +2. And that charge we call the oxidation state. And I will guide your eyes to them in a moment on your periodic tables. Again, you've heard of the term univalent. Un, you just saw it many times. One. Univalent means it has only one possible oxidation state. It can only have one possible charge. And then we have multivalent. There are some ions that can exist in more than one stable oxidation state. So let's just take a look at some of these. So if we're talking about a univalent metal, I don't have to call that sodium 1 because there's only one possibility. I just call it sodium. And I need to know that sodium is going to have an oxidation state of 1. And same with zinc. Zinc's a transition metal, but it only has also an oxidation state that is 2. There's only one of them. So I don't say zinc 2 because there's only one possibility. I only have to put the Roman numerals if there's more than one possibility. So if I'm dealing with iron, 2 possibilities. There's iron 2 or iron 3. All right? And this old periodic table has a 6, and I don't like the 6. Does yours have a 6 on it? Does your iron have 2, 3, and 6? Good, because I'm not a fan of the 6. It's a very rare one. 2 and 3. Okay? When there's more than one oxidation state, it's been determined scientifically that one state is a little more stable than the other state. That it hangs around in nature a little more. Actually, given the right chemical situation, the other state will eventually turn into the more stable one. Given a right chemical situation, it'll actually turn into the other state. It'll trade an electron away. Notice that in your numbers as well, that there's a bold number. All right? And for iron, which one is the bold number? 3, which means the iron in the iron 3 ion is a little more stable than the iron 2 ion. All right? Given the right chemical situation, the iron 2 ion will get rid of an electron and turn into the iron 3. But we can make iron 2 compounds. They will exist, for an extended period of time. It won't completely disappear right away. I cannot make a magnesium 3 compound. It doesn't exist. And therefore, magnesium only has one possible oxidation state. Okay? Because sometimes we'll need to talk about which one's more stable. So we need to know that bold thing. Okay, so just put down here examples. Just put e.g. Even though we didn't write the other ones down, we'll go through of them here. And again, just e.g. And let's name these. So we're talking about the metals. The name's not changing. The question is, do we need Roman numerals or not? Do we need to distinguish between 2 possibilities? How many possibilities for silver? Yeah, Chelsea? Everybody said it? That's great. 1. So do I need the Roman numerals? No. So what are we calling this metal ion? A silver ion. All right, a silver ion. So this is just called a silver ion. Excellent. Copper, taking a look at copper. More than one choice. Yep, we're getting some nods. So what's that one going to call? Let's go hands up on this. What's that one going to be called? Yeah, Christopher? It's a copper 1 ion. Copper brackets 1 ion. All right? So when you're given, especially a transition metal, you've got to do a quick check to see if it's one that has more than one choice or not. Just do a quick look, quick check. When you're given the name of it, it's kind of easy. Nickel 3. How am I going to write that? It's going to be the symbol nickel. And now what do I put on it? What's the charge going to be, Dallas? +3. +3. It's a metal, so it's got to be plus. And it's telling us the charge on the ion. +3. That's easy. It's like they're telling it to us. If I'm asked a cadmium ion, this becomes trickier because I actually have to find cadmium, and then I got to find out what the charge is. What's the oxidation state of cadmium? Is it +2? Cd +2. So you need to be good with your periodic table. You need to be able to find things, right? I need you to know where, these cadmium's one of these guys here, +2. Got to be able to find it fairly quickly. Okay, let's now put it together and do some compound naming here. We did some compound naming yesterday when we did some Lewis diagrams. These examples are all univalent. It means that the metals all have only one possible oxidation state. It means that I don't need the brackets for this. I just have to name them. This is pretty straightforward business. I've got that ion and that ion. What's this called? Hands up, what do we got? Christopher? Sodium chloride. Don't wait for me. This is as straightforward as it is. Keep going ahead in front of me until I break your concentration to give me an answer. So don't wait for me to do these. Same with any examples we do. Get your pencils out. Go ahead if you think you know, because this is review. Somebody got number 2? Yep, what do you got, Atlee? Aluminum oxide. Somebody have number 3? Yep, what do you got, Chelsea? Yep. Magnesium fluoride. Again, pronunciation, very important to get the correct spelling. I don't really care. Fluoride, but fluoride is the way I have to say it. Dallas, what do you got? Zinc sulfide. Okay? Univalent, no brackets, Roman numerals, don't have to worry about it. Very straightforward. Okay? All right. Let's talk about determining the formulas. So formula of ionic compounds, whether you call it the crisscross rule or the crossover rule, do not write this all out. This is stuff you've done for years figuring out formulas. If you want to make a reference to your text, you can say see page 90, and it talks about writing the symbol, then write the oxidation state, then cross them over, then cancel out any common factors, bring it to the lowest common factor, write your formula, right? So this is not new. Again, whether you call it, I always called it the crossover rule. The teacher that made this PowerPoint called it the crisscross rule, whatever you want to call it, it doesn't matter. Again, see page 90 if you ever want to make reference to that. But it's pretty straightforward. I'm hoping you guys, have seen this. Okay, so next slide, a bunch of examples. Again, if you are comfortable with doing this, You can just go ahead and do this. I don't actually need you to write down the oxidation states, but some people do, all right? So silver nitride, and I'll do that one very carefully with everyone. Again, you may know, you might be able to just do the crisscross in your head, look at the oxidation states, get the formula. That's great. That's where I want you to be when we get to a test. I want you to be where you're just doing it in your head and you're not having to actually write it all out. But to write it all out, I've got silver, Ag. What's the charge on a silver ion? Hands up. Yeah, what do you got there, Janessa? +1. And nitride, what's going to be the charge on a nitride? Now, nitrogen has some other options, but I want you to keep your non-metals as just what it is to get it filled. Atlee, -3. So now we crisscross. Here we go. This is the fun part. All right. I don't need to see any of that stuff. This is grade 9, grade 10. I'm hoping you're looking at me going, wow, really? You're going to draw arrows to guide our eyes here? Ag3N, because we don't write the 1. Sound familiar, everybody? Again, review, but we do need to take the time, make sure we're following the proper stuff. So again, you can go ahead. You don't have to wait for me. You're going to give me an answer? Oh. No, because the negative just represents the charge. When we cross them over, it represents the number of atoms, right? And really where this comes from is yesterday's Lewis diagrams, right? From yesterday's Lewis diagrams, if we drew, and it would be hard for a silver because silver's got a bunch of funny electrons, but silver would need 1, and nitrogen silver needs to get rid of 1, nitrogen needs 3. You remember how we did that? That's where it comes from. So the negative charge, as soon as you crisscross it, turns into the number of those atoms of that type. So no negative written in there. It becomes a number. Does somebody have one for zinc chloride? What do we got? Formula. Don't tell me the charges. I just want the formula for zinc chloride. Yep, Dallas? That'd be a ZnCl2. It's all right. ZnCl2. Okay? Zinc 2, chloride -1, cross them over, ZnCl2. Magnesium sulfide. Yeah, Chelsea? Yeah, very good. MgS. MgS. Now that comes from, and again, I'm hoping everybody knows why it's MgS, but if not, we'll take the time here. Mg is +2, S is -2. We cross them over, right? That puts 2 and 2, but remember, we have to cancel off any common factor. That gets us to MgS. So that goes to 1, that goes to 1, and we have MgS. All right? It is the simplest representation. Yes?
How do the bolded one was the most common?
What element are you talking about? Sulfide. Okay, so let me go back to the statement again. For the non-metals, I need you to pick -1, -2, -3. And that's because we do not have enough information to tell you why it's anything but -2. So I need you to use -2 for the non-metals for sulfur every time. All right, we will worry about all the extra numbers for the non-metals at a later time. Okay? All right? Okay. Let's now talk about multivalent ones. And then we'll mix them all together and see if we can pull them apart. So now we're dealing with the ones with the Roman numerals. It means that if I'm doing a formula and I'm told the Roman numeral, it's easy. But if I'm doing a name and I got to figure out what Roman numeral to use, that's a little trickier. Because there is more than one possible oxidation state, you must indicate with your brackets and your Roman numerals which one you're talking about. This becomes very important in writing reports on, say, a chemical reaction that you are doing. Or perhaps if you're working in a laboratory situation and you're a technician or perhaps an assistant to a technician, and that technician says, I need some iron chloride. You would then proceed to the storeroom where you find your chemicals, and you'll find that there's two versions of iron chloride. There would be an iron 2 chloride and an iron 3 chloride. And you would then not know which chemical to return to the technician. So when there's more than one option, you must always indicate with your brackets and Roman numerals which option we're talking about, so it doesn't mix up those two different chemicals. Every chemical must have its own individual name to identify itself, to prevent, ambiguity, mixing them up of chemicals, etc., etc. When doing this, it is actually easier than the univalent ones. When we were dealing with silver and zinc and cadmium, you've got to go and find those numbers because they're not in a logical location. With this, they're telling you what the number is. You can actually get the formula easier for these guys because you don't have to go hunting for the numbers. It's given to you. Again, go ahead. Cross them over. Cancel out what you need to cancel out. Don't wait for me. Somebody have an iron 2 chloride? Somebody's got to be done that first one. Yeah, William, what do you got? FeCl2. 2 is given. Cross it over. Cl is in group 17 minus 1. Cross it back. Beautiful. What's the symbol? What is our formula here, Janessa? HGO. Excellent. HGO. AU3N. Excellent. 3 and 1. Lead 4 sulfide. And what do we got? We got too many, the same name here. What do you got? PBS2. Yes, because the 4 went there, the 2 went there, and we cancel off a common factor of 2. Okay? Excellent. Let's keep rolling. Now to go to the name. And there are a couple of ways of doing this. Because now we have to decide, one, if it is multivalent. So you look at the iron and you have to say to yourself, does that have more than one oxidation state? And the answer is yes. The answer is yes for all of these. But when I mix it up, you've got to decide that, right? So again, if you know where iron is quickly, you can quickly take a look for iron. Oh, look, I got 2 choices. I'm going to need Roman numerals for that. The next thing is you got to determine which Roman numerals that you're going to use. 2 ways to do this. And I'm a fan of the second way. The first way we would call the reverse crossover, right? We would, in our minds, bring the charges back to where they originally came from, 3 and 2. But that only works if a number hasn't been canceled away. If something's been canceled away, that doesn't work because we've canceled the number away. In this case, by using the reverse crossover, my 2 goes back up with the oxygen and my 3 goes right there. So this is an iron 3. Okay? But let me show you one other way of doing it, and I like this even better. I'm going to clear this out of the way. It has nothing to do with writing anything down, but it has to do with using your periodic table quickly and easily. I take a look and I see that I've got 2 choices, and I've got iron 2 or iron 3. I know I'm up against oxygen. If it was the 2, what would have happened to my numbers? Canceled away. Can't be 2. If it's 3, in my head I do a quick little crossover. Oh, that's the exact formula that I would have got. So what I actually do very quickly, because I'm good at it, is I go to iron, I look at the possibilities, and I see the only thing that can give me that formula is iron 3. And so I actually make the formula for iron and oxygen depending on which one gets me the right formula. And after babbling away, I've lost my train of thought. What type of iron is this? This is iron 3. So this is iron 3 oxide. Okay? Again, looking at the nickel. There's my two choices. It's up against sulfur. Sulfur's right there. What type of nickel must this be? What type of nickel must this be? Yep, Braden, what do you got? 2. Has to be 2, because it's going to cancel out with the sulfurs too. And I like that way a little better than this reverse crossover, because if you do the reverse crossover here, you're going to go 1 and 1, and if you're not paying attention, you're going to think it's 1. But when you do that, you've got to realize, oh, but sulfur's normally 2, which means we canceled 1 away, which means it's still going to be a 2. That takes a lot of logic. Much easier just to look and quickly do it in your head and figure out which one it is. And again, as I've babbled away, I'm going to scribble that all out. What was this? Nickel 2? Oh, it's nickel. It's not nickel. All right. Nickel 2 sulfide. Pronunciation is very important for me, especially with words like skizzers and muscles and diaphragm. All those science words with those hidden letters in there. What's that? Oh, pneumonia? Yeah, I agree. All right, what do we have for this one? Again, I'm not going to look. You guys do a quick check. Dallas, what do you got? Chromium 3. Chromium 3. Oops, put an extra one in there. Chloride. Excellent. Next, yeah, what do you got there? Lead 2. Let's take a look. If I bring the 2 up here, right, then the 1 goes up there, but oxygen is normally a 2, which means it had to cancel away. It's got to be the other one, obviously. There's only 2. It's going to be lead 4. It's lead 4 oxide, and that's where the reverse crossover catches you. You look at the lead, you see 2 and 4, and you think, if it was the 2, Haley, if it was the 2, and we did 2 and 2, what would happen to the 2s? They didn't cross each other out. But they didn't cross each other out, did they? So if it was the 4 would go there, the 2 would go there. I'd cancel down to 1 and 2. It's got to be lead 4. So that reverse sometimes gets you. That's why I'm a fan of quickly coming up with the formula. Oh, look at here. I got an O again. O can be tricky. Which one is it? Yep. Yeah, it's mercury 1. Mercury 1 oxide. In this case, the reverse crossover would have worked, right? But you never know, right? So you got to do a quick check. All right, excellent. Let's now mix a few of them up here. Oh, yeah, that's just me doing the reverse crossover, and I'm not a fan of that. So let's now mix some of them up, all right? Some of them are multivalent. Some of them are univalent. The multi, you got to have brackets and Roman numerals. The univalent, you don't have to when doing the names. These are obviously determining formula. So go ahead. Don't wait for me. I'm actually going to wait for you to finish these, or most of them anyway. L-I-F. 1-1. Ag2O. Zinc nitride. Yeah, go ahead. ZN3N2. Excellent. Next. Somebody got something? Yep, go ahead. CRSE2 and 2. Excellent. They canceled out. You got the last one, Chelsea? AuCl3. All right? Name these. What do we have? Name for the first one. Yeah, Chelsea, what do you got? Yep. Did we already have that? We did, because I said magnesium, and then fluoride. And I think it was with a magnesium. One of those is an R, by the way. How about the next one? Yeah, we got Joy. Excellent. Mercury 2 chloride. Next. Yep, Dan. Excellent. Lead 2 sulfide. Next, William. Silver nitride. Silver nitride. All right. Next, go ahead, Janessa. Chromium 3 oxide. Yeah, I like it. Chromium 3. Sorry. Yeah. This is me. That was me. You're right. That was a Friday moment. I was thinking about the Leafs winning. It's correct. Yep. Yeah, very good. Tin 4 oxide. Tin 4 oxide. There's a bunch of practice problems. Now, I'm not going to let you work because I do want to talk about the classical naming system. The classical naming system. Now, this naming system only deals with the multivalent guys on the periodic table. So all we're really learning now, just here at the end, is how to name the ones with the Roman numerals in the classical system. Okay. This system with the us and ik ending can be used for any element that has 2 oxidation states. If the element has a Latin name, the Latin name is used. So for iron, the Latin name is ferrum, and therefore we use ferrum as the base name. So for the low oxidation state of 2, it's ferrous, and for the high oxidation state of 3, it's ferric. And that's just the way it was done. Again, where does the us and ik ending come from historically? I don't know. Chemists, though, sometimes when we have to learn something that we don't know the background for, make a silly little saying. And our silly little saying for this is us, O, low, ik, I, high. Ik starts with I, you think of the high one. Us starts with O, you think of the low one. Okay? Now, the length to this lesson, and I am looking at the time, the thing that makes this a little long is that we need to go over some Latin names for the elements. All right? So I do need this written down. You don't have to draw a fancy table. You really only need 3 lists. The element, the Latin name, and then the ion name. Okay, so 2 possibilities for iron is ferrous and ferric. For copper, it's cuprous and cupric. And I think is it 1 and 2? You check. You check my numbers. I'm just going from what I remember. Is it 1 and 2? All right? So when you get a name like cuprous, you still have to go back to the copper and pick the low one. Stannous and stannic. That's one of my favorites. I like that. Stannous. It's good stuff. I should have named my kid Stannous. That would have been funny. No, he wouldn't, but it would still be funny. Oh, Stannous. Okay, let's continue. What are my 2 numbers for tin? 2 and 4. So Stannous is low, plus 2, plus 4. Yeah, I got to watch what I say about my kids anymore because all you guys know my kids. Man, I've entered a strange part of my career. Okay, now lead. The Latin name is plumbum. You may giggle about that. It is funny to say. It's funny. It's funny sounding thing. This is plumbus and plumbic. And it's 2 and 4 as well, I think, isn't it? Plus 2, plus 4. Okay? That's why people who work with pipes are called plumbers. You've got to put the B in there, I just spelled it wrong. And that's because the pipes they used to use were lead. But now we know lead is a toxic metal when it gets into the water system, so now we use copper. Cobalt. Now notice it doesn't have a Latin name, so we just keep the regular name, cobaltus and cobaltic. All right? So we can have a Nicholas and a Nicholic. Funny too. It's just funny to say. So if they don't have the funny names in here, then you just keep the regular name and you put us and ending on it. Let's not worry about the charges anymore. I just want to get to the bottom at this point. For gold, we have Aurus and Auric. So you are going to need to memorize these Latin names. Mercury has a funny one. It's called Hg because it's like Harargium or something. I don't even know how to say it. I never say that word. That's where the Hg comes from. But yeah, that's where those symbols are coming from. The symbols that are strange are coming from the Latin names. Yeah. Yeah, that's where our Cu comes from for copper. So for Mercury, because, and I don't know why, maybe because no one can actually say this word, they say Mercurus and Mercuric. Mercurus and Mercuric. And antimony is stibnium. Again, like where does that come from? That's where it comes from. Antimony is stibnium, and so that's stibnus. That's funny too. And stibnic. And again, you can check your table for the charges. All right? Okay, now for a couple of examples using the classical naming system, so we can give you some homework and then you can work on this in class tomorrow. All right, plumbic chloride. So again, the classical naming system ends in ic or us. That means we're dealing with lead, Pb, chloride, Cl. If you check your periodic table, you'll find the 2 oxidation states for lead is 2 and 4. So remember, if it's ic, it's the high one. So this is lead 4, chlorine is 1. And if we cross those over, that is PbCl4 for plumbic chloride. All right? The next example is cobaltus sulfide. So CO and S. Again, if you check your periodic table for cobalt, its 2 possible oxidation states are 2 and 3. So us is the low one, us-O low. So this is 2 on the cobalt and 2 on the sulfur. And so when you cross those over, that is COS. All right, now let's do a couple of them where we figure out the names. So here I've got FeCl3. Again, we can use the reverse crossover, bring that back up. The 3 goes with the iron, the 1 goes with the chlorine. Chlorine is normally 1, so this is iron 3. If you check your periodic table, iron has possible oxidation states of 2 and 3. 3 is the high one, so that makes it ferric chloride. All right, because the high one is ic. And I have SNO. Now we got to be careful with the O. Again, if I do the reverse crossover, we get a 1 up there with the tin and a 1 up there with the O. But the O is normally 2, which means they've got to be 2 and 2. All right, so you got to be careful with that when we've got an O on the end. So since it's a tin in the 2 form, and if you check the oxidation states for tin, their choices are 2 and 4. Because this is tin 2, it's the low one. So this is stannous oxide. All right? So there are a couple of examples on the classical naming system, and there is a homework problem that you can then do for that.